Hey guys, Rick here. Back again with another video. I was trying some logic gates. Hope you can. The main logic was I was trying to make a sorter. So like for you to sort, it needs to be like from the lowest to the highest or from the highest to the lowest. So there you can sort for 4 bits. But this is slightly harder, so okay, it's longer. I settled for 2 bits. I haven't got optimum results, but yeah. So the first analogy was to have a switch. The switch is connected to a NOT and there's a true. So for this switch I can get 0 and I can get a 1. This is for comparison. I'm using it as a memory. So and then I have A and B. So I'm trying to sort A and B. When you look at order, it's A, B. So this is either 0, 0, 0, 1, 1, 0 or 1, 1. So for you to sort, when it's 0, 0, it should have no change. When it's 0, 1, for ascending, it should have no change. For 0, 1, 1, 0, it's descending, so it should change. It should flip the A to 0 and the B to 1. And for 1, 1, there should be no change because they are the same. So I started with A, bit A and bit B. So it's either 0 or for A's it's 0, 0, 1, 1. For B's it's 0, 1, 0, 1. So I tried to compare the A. I'm comparing the A's to see if it's a 0 or a 1. That's the only way I can know if it's a 0 or a 1, or I can let the machine know if it's a 0 or a 1. Obviously human can tell. So if A is 0 and this, so we take a line from this and a line from A, pass it through an equals. When it passes through an equals, so if they are the same, you should have an output that is 1. So that will represent A naught. A is 0. If A is 1, the same output is coming. Where is it? Here. Going like this over the loop, entering into this not equals. So this equals is being compared to a 1. So I'm comparing it to 1. So if it's true, I'll get a 1 here. So if it's 0, it's a 1 here. If it's true, it's a 1 here. Same happens for B. I'm comparing B with 0, B with 1. So I'll know if it's A is 0, if A or A is 1, or B is 0 or B is 1. So after that comparison, we saw from this one, there's only a change when A is 1, B is 0. There's no change during other states. So in this comparison, you take the signal from A1 and the signal from B0, put it through an XOR. Give me a minute. Sorry, I've made a mistake. This is supposed to be an equals. So the output of change is coming from here, not this one. So I can cancel this. Sorry for that error. Either way, it's not bringing. Okay, from the simulator that I'm using, I'm having an error. The equals. Okay, the equals is for you to get an equals. Give me a minute. I set up here. Sorry, made a mistake. This is supposed to be an equals, not an XOR. I was looking at 0, 1. So for it to, when it's equals, when A is true and B naught is true, there should be a change. But the problem is, for the simulator that I'm using Prison Architect, equals only comes true when there's a 0 and a 0. When it's a 1 and a 1, it still gives you a not. So it looks like a 0 0 0 1 1 0 1 1. The output is here for equals get. This is 0, this is 0, this is 0. It looks like x nor. So let me show you. Give me a minute, I said. So for not, like I've connected these two gates. This gate here, you see it's a not. I've connected this gate to this not here, sorry, and let me show why. So I've connected this gate to this not, and this gate to this not. So we see that. So I want you to observe the output of the not. So when it's 0 0, when it's 0 0, the output is 0, it's equals. When it's 1 0, the output is 1. When it's 1 1, at least I should get a 0, but still the output is still 1. And when it's 0 1, I'm still getting an output of 1. So I got a slight error with the equals. So but the plan was for you, after I get a signal here, this change comes here. This was planning, so I'll assume this. So passing through here, and then I was getting a signal from B, but it needs to be a B note. So I'm taking B, I'm taking a B, passing it through a note, getting it here. I should be getting the B from here. So for change and B note is I get another B note, and then I got an error. Another error. As it was flipping, I was getting for 0 0 it was remaining constant. For 0 1 it was remaining constant. For 1 0 it was not changing. There was no change, and this was the main one. And then for a 1 1 it was remaining constant. Okay, for a let me try to remember. For a 1 1, not for a 1 1, for a 0 0, I was getting it was I can't really remember the output, but I came here for 0 0 when it's equals, when A0 and B0 is equals to each other, you note it, pass it through an XOR, and then change. So change is either active, and then this it was for when the output is 1 1, I was getting an error, a slight error. So I needed to for 1 1, this will be off. 1 1 it will be equal. Let me try to for 1 1, for the equals, it's supposed to be for 0 0, it's supposed to be active. For 1 1, from the game it's 0. So when they're different, there's more change. So change and then a not, you note it, you get a 0. So when it's that 1 1 or what 0 0, there's supposed to be no change because the data is the same. You can't flip, you're not supposed to flip them, both of them. So so here the output, the input will be a 1 and a 0, so it's supposed to be true. So this true, I was bringing it back to the B, to flip B. So at least you get at least a 1 1 or a 1 0. So I was getting a slight error. So trying to improve on the results on the not, we came up with a second idea. So there is A and B, and then there's a signal from X. So X is being passed through a not, and the true signal is coming from here. So this is the same as here for the equals, but now I'm using an XOR. The truth table of an XOR is 0 0 0 1 1 0 1 1. For XOR it's 1 1 here, 0 0 here. But since I need them to be equal, I'm checking if A is 0 or A is 1. So I'm coming XOR. When A is 0 and the signal from here, the memory is 0, it will confirm that I have a 0. When they are not changing, when I have a 1 from here and the signal from X, the memory from X is 1, I get a 0. So it's supposed to be, it's true either here or here. But since I want these zeros, so I'm noting it. So it's becoming, after noting it, the output becomes 0 1, 1 0 0 1. So for example, this for A, and this for A and B. Just take for A and B, any two lines. So coming to A, I'm taking A, and then it's being fed into this XOR. The second signal is coming from 0. So if A is 0 and X, and the X signal is 0, you see it's a 0 0, and then from here 0 0 and then not in it, so XOR and then a not, I get a 1. So it confirms I have A0. Hope you've gotten it. And then for A1, it's the same. I'm taking a signal from A and then a signal from X, comparing it now to the X1. This is not the not 1. This is comparing it to 0. This is comparing it to 1. So when I compare it and then I get a true from here, I'm supposed to know that I have A1. A is 1. So the same is being done for B. Signal from B, signal from true. So the true side, I get a B1, and then signal from B and signal from the not side, I confirm that's a B not. So having those, I have an A1, B not. When I have an A is 1 and B not is, and B is 0, there's supposed to be a change, because I want it to go in ascending order. A should be 0, B should be 1. So there should be a change here. When A is 0, B is 0, there should be no change. The data is the same. When A is 0, B is 1, there should be no change. It's ascending. When A is 1, B is 1, there should be no change. It's equal. So having that concept, I came here to signal A1 and B not, the one that I want. So if it's true and this is true, having it through an AND. So like A is 1, that's true, and B is 0, that's another true. The AND, this is an AND gate. Sorry, I had mistaken it for an XOR. This is an AND gate. Oh, sorry. This is an and looks like this. So when A1 is true and B0 is true, I should have a change. Now, okay, I'm still pushing it on. So when there's a change, you feed back this signal to flip B, to make B1. So at least you can have like an A that is 1, B is 1. So you don't have it will not particularly sort, but it will be A will be 1, B will be 1, because there will be a change. Now the error is when this flips this B back to 1, now the signal, the data reads 1 1. When data reads 1 1, we come here, so there's no change. I haven't it will help you sort out if the data is ascending or not descending, but it's not fully sorting. So you see, when I'm getting this back, I'm getting a 1 1, and I need it to flip the two results. Trying to flip it back using a NOT, I get an error. So let me show you. So here, this is the X. So this is the X, this one here, and then this is A, this is B, A, B. Now from show wire, you can see that I'm noting the signal from NOT, and then it's coming to the first XOR, and then I'm comparing it to this one. So I'm comparing to check if A is 0. The output comes to a NOT. Remember, you need to note it because of here. The XOR only works for when either is true, but I need when either of them they are the same. So from there, getting the two notes, taking it to an AND, I'm taking it to I'm not in it first. I'm not in it, and then taking it here. It's the only way I could get an output. Let's try. Okay, I've tried that. So the signal from the change is coming, being noted, and then coming here, coming to B, and then the signal from change is coming here, flipping the results. Let's let me can't remember the so when it's a 1 1, there's no change. When there's a 1 1, the beak is not turning off. That's the error I'm getting. But when it's a there's another error. When there's a it's 0 0. When it's 0 0, it starts oscillating. So at least you'll know the output is a 0. But when you get a 1 0, it's not flipping them. The original one was not this setup. When it was a 1 0, it was staying at 1 0. But here when it's a 1 0, it's flipping the 0, it's sticking at 1, and then the B stays active. Even if I try to turn it off, it doesn't turn off. But for you to turn it off, you turn off the A, and then it will turn off, because it will start oscillating. If you follow this line up, you will see that when B is 0, this will go off, and then it's noted, and then since it's noted, it will be active, so B will be 1 again, starting oscillating. And then when it's coming here, it's noted again, coming back. Let me show you the result without the note. The result without the note, it's here. Coming here, so when it's not noted, when it's 0 1, it's staying at 0 1. When it's 1 1, it's flipping. There's an error. And then when it's 0 1, stays like that. 1 1 starts oscillating. Goes to 1 0. And for 1 1 goes off. So it's better off taking it here, noting it first, and then putting it through the so that's it. I'll try to improve on it. Thanks for watching. Please do share, like, and subscribe. Thank you.